Assalamu alaikum. I welcome you all in this lecture. Today we are going to discuss about the randomized trial. This is basically a continuation of my previous lecture where we discussed about the prognosis, and in order to understand the important elements of a randomized trial, we are going to study. But before we study about the randomized trial, we could say that the randomized trials are also called as randomized clinical trials. So a bit background with examples. What you are looking right now is a famous physician of French origin. His name was Ambroise Paré, and he observed his initial findings on a randomized trial, and that was like an accidental trial, more like that. Upon the invasion of a castle, the name of a castle is Castle Velen, there was a certain group of soldiers who were wounded, and the person who is responsible to look after their wounds was this physician. And he says that he used to apply oil, in fact not oil, that was a boiling oil, on those wounds, so that the wound get cauterized and there is no seepage of a blood. But during the invasion and victory of this castle, a lot of soldiers were injured, and he ran out of that boiling turpentine oil. So instead of that oil, he used yolk, egg, oil, rose, and certain other stuff. So he was of the opinion that on his next day he would seeing those soldiers died of agony rather than the ones who were supplied with the boiling oil on their wounds. To his great contrast, he observed that the individuals who were supplied with rose oil and egg yolk supplements were much better as compared to the soldiers in which he literally introduced boiling oil. So this is a pre-native example of how the man evolved certain hidden trials to get the beneficent effect of one treatment over another. In continuation to the same example, there is another interesting example which is observed in UK, and in the Great Britain it was known that a physician whose name was James Lind, he conducted a trial against a disease which is called scurvy. Scurvy is basically vitamin C deficiency. It is caused by a deficiency of vitamin sea. So all those sailors which were remain on the sea for quite long time, they are deprived of vitamin C, and this physician actually conducted a trial in which he used lemon and oranges as a supplement dietary elements, and he proved that with the administration of appropriate lemon intake, that the Scurvy disease, which is basically affecting them and it's quite debilitating at that time, could be improved. So later on, that trial findings were being incorporated. Based on those trials, the Navy Admiral has opted that lemon and lemon related juices should be given as a dietary supplement to all the seamen available. So this is a classical portrait of James Lind administering a lemon juice to these seamen. So basically what I'm trying to present over here is a building up a case of randomized trial, and it is not a new thing. People are already opting for this technique. So what is the general layout of a randomized clinical or a field trial? We generally use the word clinical and omit it over the passage of time because it can be extended to certain other spheres as well. So if you look on this photo, you will see that there is a study population, and then the study population is randomly assigned. Let me draw a star over here because this is a very important step. So the study population is randomly assigned into two parts. The first part is going to follow the current treatment plan. Over there, a certain number of people doesn't improve, the treatment doesn't work on them, but a certain proportion will improve with the passage of time. And the new treatment, which is treatment in question, can also be given an improvement and don't improve patterns were observed. So this is the basic schematic structure of a randomized trial. So what kind of parameters should be taken in account? while designing a randomized trial. The first and the foremost thing is that the study parameter is that it should must be defined at the start of the study. What? Inclusion criteria. What members, what kind of individuals, gender, or species should be included in this study. So there is a inclusion criteria which should be defined right at the beginning of a study. So this is the most important step. So what kind of patients, individuals you are going to enroll for that particular study design. Then we need to compare them. Without a comparison, it would be difficult to establish whether treatment in question has some advantage on the already existing treatment, or there is nothing to measure the contrast. So we always need controls. These are the two paradigm important parameters one should take in account regarding the randomized trial. So the first parameter says sometimes we are dependent on the historical controls, and those historical controls are already available, hospital records or registries from where we use a referral point that we are comparing our findings in contrast to an existing control measures. So sometimes from historical records we compare uh, for our study, draw a comparison. Now, there are two things we should take in account. Number one, the kind of study we are conducting and the quality of the study we are making from that. So, and then the challenges of like change in environment, nutrition, and the age status. Let me explain this with one simple example. Let's say we are studying the effect of cholera, and we want to study whether the cholera incidence is higher in winter, and we are comparing a study which is started. We want to enroll a group of individuals in December, and we are comparing those findings with what we have already noticed in flooded area in June. The comparison is being affected by two factors: change in environment. In December, there is a limited flood or rainfall as compared to what we have noticed in a floody area, or an area which is already affected with a particular disease in June. So the time duration and the comparison of that control is critical measure to follow. Then there are certain problems with the historical records, like for example in most of the hospitals their intention is just to enter a patient basic information, not about the disease progress, onset, disease diagnosis, or the clinical complications he is suffering from. They are more interested to enroll the patient name, weight, height, and thus the preliminary parameters. So, from a treatment perspective, a historical control may be challenging upon these factors of quality. Okay, so these are the two core things which we need to take in account. And another thing, in contrast to historical controls, one could opt simultaneous non-randomized controls in parallel. So what do you mean by simultaneous non-randomized controls? This is basically a control which is opted during the commencement of that trial. So example, the very interesting example is that let's say there was a drug which is called as anti-nausea tablets. Anti-nausea means anti-vomiting tablets, and they were given to a sea captain, and the sea captain was given an advice to check the efficacy of these anti-nausea tablets. Upon his return, he says that all the tablets work very fine, in contrast to what we have noticed in the controls. Now, the controls were all those individuals which were normal passengers, and the captain take a sort of biasness and give these tablets all to the seamen. A sea captain was given this samples of anti-nausea pills to test during the journey, so the need for control was carefully told to them. But upon his return, the captain says that practically every one of the control was ill, and not one of the subjects who has had any trouble. So this is like a pretty, what you can say, surprising thing. that the individuals who were in question were the seamen, and the controls got sick. So this is not a very ideal case, all right? And in second example, if we say that we assign patients in order to avoid that thing, so simultaneously non-randomized controls may pose a problem. And then in order to that address this issue, sometimes we divide our cohort into based on that there are certain number of even dates, not certain number of odd dates. So the patients who are visiting on these dates will be given a treatment B. The patients who are visiting a hospital on date odd dates would be assigned a drug A. Okay, so based on this, this we define our controls and go strategically further ahead. And additionally, there are certain other things that a predefined pre-bias by a pre what you can say selection biasness may also can badly influence our results as well. So look at the example of effect of Bacillus clamlet guerin, and this is basically a vaccine which is used for the for against the TB. So earlier it was administered to the kids, and the number of deaths were reported were 3, and in controls the number of deaths were reported 18. Now this is an interesting thing, that the administration of a vaccine is increasing the number of deaths by TB, while we would suppose that the Bacillus clamlet is more helpful for the kids. So we say that the vaccine is pretty much effective, but there is a predefined biasness which is influencing our results. It has been noticed based on the observation that the vaccinated control individuals were all those who were what you can say more cooperative kids were being reported on this finding. Then the physician reports that all the individuals who are the careful parents in which the vaccine was administered, they were more intelligent and cooperative parents, and so the number of children who of non-cooperative parents died more in number as compared to the parents who were more cooperative for the trial. So this defines that the vaccine was selectively performed to the children from families of cooperative parents. Over here, the key is the cooperative parents, as compared to the parents who were not which much cooperative in the eyes of a physician. So, a more conscious trial was done, and the vaccine was given to address this problem, and that problem was being addressed, that alternate childrens were given like randomly. Some of the children who were visiting were given this drug and the other one were given this. So there is no predefined background criteria set at this stage. Over here the physician was biased. He was administering vaccine to the cooperative parents as compared to the non-cooperative, or yet you can say poor parents. The kids were not given the proper vaccine. Over here, randomly, let's say on odd numbers or on even dates, these kids were given the drug, and then the analysis says that the deaths due to tuberculosis deaths were almost the same. So there is no advantage of tuberculosis related death noticed in this trial. Okay, so this is how much the influence of background parameter inclusion criteria is on the results, right? So the core purpose of randomization is to prevent any potential biasness on the part of investigator from influencing the assignment of participants to different groups. I mean to say that if the discretion of administrating a vaccine over a plebiscite for, let's say, COVID-19 is given to an investigator, he will try to administer as much as vaccine as compared to plebiscite to the general population. So that, and that what you can say, that power of decision should be kept in what you can say, it could be kept as a secret in the eyes of investigator as well, okay, so that the randomization should be attained. Now let's go for further. Let's say a total of two. Now I am elaborating this with the following example. Let's say a total of 200 individuals suffering from myocardial infarction were subject to intervention. So now we are trying to study how a randomized and non-randomized trial can alter the case fatality rate, the rate which we have studied earlier, the number of deaths divided by the number of people affected from that particular disease, right? So we say that there are 2000 individuals who are suffering from myocardial infarction, and we subject them to intervention and we put them to a random assessment. So interestingly, we say that 700 have an arrhythmia, irregular heartbeat, while 1300 doesn't have such any further complications. So we say that with arrhythmia case fatality is 50%. So the number of individuals who die with arrhythmia are 50% case fatality rate. In contrast to the number of people who doesn't have arrhythmia, the number of patients whose death is 10%. Okay, that's important to remember. Now in non-randomized study, out of 2000, 1300 individuals were non-arrhythmatic, 700 were suffering from arrhythmia. We just randomly divide them into equal numbers of 1000 over here and 1000 over here by saying that, let's say, 800 falls over here, 200 arrhythmic over here, 500 goes with this part. And then we noticed that since the case fatality rate is 50%, so we say that out of this 1000 folks, out of this 1000, we say that 180 deaths were reported. So the case fatality rate of myocardial infarction, is reported 18% and 30% in intervention and no intervention trials. But this is a non-randomized assignment. This is a non-randomized assignment. Over here we are observing whether the intervention of our interest, let's say we want certain group of individuals to be hospitalized and certain number of individuals to retain in domiciliary care, or what you can say at home care. So based on this non-randomized assignment of not dividing arrhythmic patients into equal halves, we are just compromising the case fatality rate. Alright, let's look on the randomized study. So in randomized study, if we look closely, in randomized study, out of 2000 individuals, 1300 individuals arrhythmia, there is no arrhythmia. We divide them into two halves, 650, 650, and so on with the arrhythmic patients, and then we observe the case fatality. Now the case fatality is being equally distributed both in arrhythmic and non-arrhythmic patients. So this is how a random assignment could significantly alter the results and our understanding. So that's how we could understand the importance of randomization. Then there are certain things we need to add as a flavor over here. We can say that sometimes the randomization is not a single core point. We can divide it based on gender. Let's say over here we can add another parameter of gender, and then we can add another bar of what you can say age at this point of randomized assignment. So in this case we call this term as stratified randomization. So out of these 2000 individuals, we add a bar of gender, and then we add a bar of age, and then we literally sublet this group into different other parts as well. Okay, so this is called as stratified randomization. And then it is essential to on the part of an investigator not to know which one is going to get the drug of choice, because sometimes it is helpful and the benefit of masking helps in certain cases as well. So this is a concept of blind testing, and sometimes we do a double blind test. So double blind test means that even the individual doesn't know, the person who is performing the test doesn't know a background status of a sample in question. Let me elaborate it with one simple story. I am working on COVID-19 specimens, and I am trying to develop a test based on RT-LAMP assay, and we are dealing with the samples who are already PCR positive, so that we can check whether the samples who are already declared positive via PCR could also be detected by RT-LAMP. So we already know that the patient sample in question is positively declared based on PCR finding, and we test them on RT-LAMP and say that the sample is also been validated on my test. But in case of double blind, the sample in question, the sample, let's say this is a sample in question, is again given for PCR and LAMP, and both neither me nor the other partner who is working on the same project is aware of the status of this sample. So this is called double blind testing. Okay, so this is the concept of blinding, the concept of double blinding. You have heard about it. Now, there are certain things during a randomization trial. In the randomization trial, there are certain planned crossovers and there are certain unplanned crossovers. Let me focus on planned crossovers. Planned crossovers mean Planned crossover means that during a trial, when you are assorting certain number of individuals in group 1 and certain in group 2, and you assign them for current treatment and the new treatment over here. So during the passage of time, at certain time point, you follow them. Then you say that this is an observed and measure effect of new treatment. This is the measure effect in group 2. With the passage of time, you say that now I want to test these individuals with a conventional treatment. So what you are going to do, you are switching group 1 individuals over current treatment and group 2 individuals to the new treatment. So you are exposing them and making a cross. Now the same group 2 individuals are followed for the new treatment over a certain period of time, and group 1 with the current treatment for a certain time duration. So this is a crossover. So in this example, if you look at this red points, the red examples over here, red points over here, what you can infer is that the same group 1 is acting as a control for itself as well. The same group 1 which was administered new treatment is also acting as a control, because it is also given current treatment at a later time point. Okay, so this is called planned crossover. Planned crossover means that the group 2 starting with the conventional treatment later some point switch to new treatment. So it is also a self-control mechanism what we are studying over here. So this is called planned crossover. Okay, and now if there is a planned crossover, there must be an unplanned crossover, right? So over here you just need to remember intention to treat. That's a very important word. So it says that let's assume that we are working on a cases, certain group of cases, and we want, there are two options for them. For example, for in a coronary care unit or in a heart disease, we recommend that certain number of individuals should be treated medically and certain number of individuals will be treated surgically. But during that decision of surgical treatment only, certain chunk of people refuse to perform surgery. So they are literally recommended for the medicinal treatment, right? So from a surgical point of view, they refuse surgery, so they are recommended for a medical treatment. But when we define that medical group and upon random follow-up, we came to know that the medical treatment is not sufficient for certain number of individuals. They need an emergency surgery. So there is a cross over here, you can notice. Okay, so there is a cross over here. So they will have to perform surgery with the yellow color over here, and there are certain number of individuals. There are certain number of individuals which require surgery, and there are certain number of individuals which don't want a surgical operation on their body. So there is a randomization at this point as well. And then the cohort size is largely been altered. In order to assess these findings, what we rely? We rely on the most primitive decision, that is our intention to treat analysis. So in this case of unplanned crossover, we believe that all surgical treatment only individuals is our day one, is the actual criteria. Okay, and similarly the medical treatment only. Why? Because over here the story may drastically be changed. Though this is a real-time data set, but in a large cohort, this fluctuation, this unexpected fluctuation is going to influence our findings. So what we say that in unplanned crossover, intention to treat was the thing which we are focusing on. So our intent was to treat the surgical treatment only, and all individuals in question were being checked. Okay, so this is how planned and unplanned crossover is being assessed. Now there are two terms which you need to just remember. Now the first term is factors to take in account in randomized trial. This is called factorial design and non-compliance. There are certain group of individuals who doesn't follow and obey orders. Those are called as non-compliance factor. And the factorial design. Factorial design means in one study you want to conduct two different treatments belonging to two different diseases in a one go. Okay, so what I'm trying to say, I want to assess whether the effect of aspirin on cardiovascular disease, and then in the same cohort I also want to study the effect of beta carotene on eyesight. So these are two independent treatments, two independent diseases. So I can do those same things on a one randomized trial because the cost of a randomized trial is huge. So in that case, the treatment option for treatment A is given over here. So both treatment A and B are administered. Let's say this is the aspirin we are using over here. Aspirin against the cardiovascular disease, and over here I say beta carotene. Let's say the administration of carrot increases the eyesight, or let's say the administration of carotene reduces the risk of cancer. Is there any supportive evidence reported in this regard? So the same cohort is being evaluated against two treatments and two different diseases in question. So this is called factorial design. So in this case, how we are going to assess for treatment A, our strategy would be, if we sum up A plus C and we divide it with B plus D, that's the value we are going to get for the factorial design value we are going to obtain for treatment A. Okay, and for treatment B, for B treatment, you can see the change in color over here as well. So for treatment B, the design of the factorial matter is, in the treatment B, in order to terminate, we can say A plus B divided by C plus D. So based on this value, the effects of these two treatments could be measured. All right. So we could evaluate the effect of treatment A by comparing the results of A plus C with, don't underestimate, don't mix up with this. You can say, let me write it in a different way. So in order to compare the effect of treatment A, what we say A plus C, that is our treatment A, versus our control. So in this case, the control would be B plus D. Alright, and for treatment B, the treatment B, the story would be different. And in this case, let me change the color. For evaluation of a treatment B, we say A plus B, and in control we evaluate C plus D. C plus D for treatment A. A plus B will be compared with C plus D to measure the effect of treatment B. Okay, so this kind of approach is called as factorial design. And the last thing which we are going to discuss is about the non-compliance. For non-compliance, you just need to remember there are a certain number of people who doesn't opt regular inspection and they fail to comply, and you need to identify in a selected randomized trials. So thank you very much for your time and attention. If you have any questions, please feel free to ask.